So this video, I'm going to talk about demand for insurance in health economics. So start from why we need insurance in the first place. Demand for insurance is driven by the fear of the unknown. People need to hedge against the risk, which is the possibility of bad outcomes. We will model that in a mathematical way and show that why is this fear a source of the demand for insurance. Purchasing insurance means that forfeiting income in good times so that people can get money in bad times. If bad times avoided, then that money, which we call that insurance premium, will be lost. So for example, an individual who buys health insurance but never visit a hospital might have been better off if they did not buy insurance and spend that money somewhere else. Okay, so the fear of the unknown, in economics, we call that risk aversion, and we'll show that in our economics modeling and mathematically. Risk aversion drives demand for insurance. We can model that risk aversion through utility from income. So this is a utility function that we're all familiar with. Utility comes from income. So utility is a function of income. Okay. Utility increases with income. So if you take derivative of utility to income, it is positive, which means that if your income increases, your utility is going to increase. The second part we're also familiar with, that is diminishing marginal utility. If you take two derivatives of utility function to income, that is actually smaller than zero, which means that your marginal utility for an extra unit of income is decreasing. Okay. On a graph, it looks like this. So on the x-axis, it's I, which is income. On the y-axis, it's U, which is utility. This curve is concave. It increases faster at the beginning, which means that at the beginning, when people don't have much income, a little bit income matters a lot. But it slowly increases slower, which means that when people have a lot of income, an extra unit of income doesn't matter as much when the income level is low. Okay, so we call that utility increase with income, but marginal utility decreases with income. Okay, so now we want to add uncertainty into the model. An individual who does not know whether she will become sick, but she knows the probability of sickness is P, and P is between 0 and 1, which means that there is always a chance that someone will get sick, and the probability of that is P. So then if the opposite of sickness is staying healthy, then the probability of staying healthy is 1 minus P. Okay, we want to model that simply into different level of income, because that translates into utility. So if this person gets sick, she's gonna lose some money because of medical bills and the time that she cannot work, which also reduces income. Okay, so then we model that as I sick and I healthy. IS is the income that she gets sick, and IH is the income that she remains healthy. And we model that as IH larger than IS. Okay, so now we want to model this into expected income and expected utility. Be careful, expected income and expected utility is different. So let's start with the definition of expected value first. In statistics, if you learn expected value of a random variable, it is the weighted average of all the outcomes, and the weights is the probability. Okay. So for example, if there are n outcomes and different outcomes value is x1, x2, and all the way to xn, and the probability is p1 to pn respectively, then expected value of x is p1 times x1 plus p2 times x2 all the way to pn plus times xn. In this situation, in the time of sick and healthy, we only have two outcomes. Okay, so then p, which is the probability of being sick, times income of being sick, plus 1 minus p times IH, which is the income of healthy. Okay, so this is the expected value of income. Okay, again, expected value of income is a weighted average of income of sick and income of healthy, and the weight is the probability of being sick and being healthy. Okay, so if you're confused, let's take a look at an example. Okay, so suppose we offer a starving graduate student a choice between two possible options, a lottery and a certain payout. So A is a lottery that awards $500 with probability of 0.5 and 0 with probability of 0.5. So imagine flipping a coin and one side will get $500 and the other side will end up with nothing. B is you can just take $250 and walk away. Okay. All right. So in that kind of situation, the expected income is actually the same. Okay. So in scenario A, we have weighted average of the lottery that awards 500 by 0.5, which is probability, plus 0.5 times 0, which is the award when the lottery is not won. Okay, it's 250. This equals to the expected value of B. We know that B is a certain outcome, but if you just put the probability of 100% or 1 into it, you still get 250%. Okay, so a risk neutral person would see this as an equal outcome. He or she will equally likely, or in economics, we call that indifferent in choosing between option A and option B. But a lot of people, or most people, prefer certain outcomes, especially when someone is, let's say, let's go back to the previous slides. So especially in this situation that we say, oh, this is a starving graduate student, which means that this person starts at a place where income matters a lot. Okay, so at that situation, we think of that marginal utility of income is high enough that he or she would actually prefer a certain outcome. And studies has found that that is the case for most scenarios, or over a lot of uncertain scenarios. We call that risk aversion, or we just call that the diminishing marginal utility, or the common utility function that we have seen that is at a low level of income. That extra amount of money matters so much that if it's certain, it's better than if it's uncertain. Okay, so now let's define expected utility. Okay, so I have mentioned that expected income and expected utility are different, but they are both expected values. So they are both weighted average of something. Expected income is weighted average of income. Expected utility is weighted average of utility. So let's say the outcome is x1 to xn, then x1, x2 to xn is the income level. Their corresponding utility level will be ux1, ux2, all the way to uxn. And as we know that the probability is P1 to Pn, so expected utility is P1 times ux1 all the way to Pn times uxn. All right, so coming back to this lottery, why does option B option B gives more utility for the students than option A? Because expected utility of option B is higher. Okay, we know that expected income is the same, but expected utility of option B is a certain utility that comes from 1 times utility of $250. Okay, the left-hand side of this equation. This is larger than the expected utility of that uncertain scenario, which is 0.5 times utility of 500 plus 0.5 times utility of 0. So in this case, even though the expected utility of income are equal, the expected utility is different. So that's why the students prefer the certain payout over the uncertain one. Okay. Or in this case, we can say that the student is acting in the risk-averse manner over the choices available. All right. So let's come back to why do we need insurance? Okay, so without the insurance, the lottery scenario is pretty similar to the situation of sick and healthy without insurance. If someone doesn't have insurance, then she gets a high income if healthy, a low income if sick. Now she is uncertain about which outcome will happen. So expected utility is P times utility of I sick plus 1 minus P times utility of I healthy. Okay. We're gonna model that onto this graph. So the utility function is still concave, this curve that we have seen. X-axis is income, y-axis is U. There's 2 red dots here that represent 2 scenarios or 2 outcomes that might happen. The red dot right here on the left is sick. So if someone is sick, then the income level is I sick, and the utility level is U of I sick. The second outcome is that this person remains healthy. So then there's a high income IH and a high utility, which is U of IH. Okay, so now what is the scenario that I think here there's an A and B. But let's ignore this A and B first. Okay, because it might be confusing to see them. We see that there is a straight line that connected S and H. Okay, so this line is actually the expected utility line, given different probability of P. Okay. So P lies between 0 and 1. Okay. But imagine a scenario if P is 1, then getting sick is 100%. So then the utility or the income will end up at the S point. If P is 0, which means that getting sick is 0%, being healthy is 100%, then the income and utility will fall into point H. But if P lies between 0 and 1, expected income and expected utility will be a linear combination of point S and point H. And when we talk about linear combination, we're talking about that P plus 1 minus P is 1. Okay. So, okay. I think it's easier to explain it in mathematical ways, but let's focus on this graph first. So if P is between 0 and 1, we can imagine that there is a certain point that falls onto this red line, okay, depending on the probability of P. So think of these points that could be the possible outcomes of expected income and expected utility. Okay, so now we can think of what's the point A and what's the point B. Okay, so if P equals to 0.25 or 25%, then this person has 25% chance getting sick and 75% chance being healthy. So then this kind of like a third quarter point of this line between point S and point H is the expected utility and expected income in this scenario. Okay, given this 25%. Okay, so you can see that I draw a blue line here that at A point, our expected income is EI 0.25. This is a linear combination of IS and IH, given that probability is 25, or given that the probability is 25% and 75%. And look at this horizontal blue line that points to expected utility of I 0.25. This is the expected utility if the chance of getting sick is 25%. Okay. All right. So in this scenario, think of a certain situation that is, what if the income is certain? Okay, what if the income is certain? Then at this scenario, the utility will be here on the utility function or on this concave utility line. Okay, so this point is higher than our point A. Okay, so that gap represents that this person, given this utility line, prefers a certain income at I 0.25, then this uncertain outcome that is 25% high income and 25% low income and 75% high income. Okay. So similarly for point B, this graph didn't show, but for point B, it's similar. So that for point B, it is for the chance of 75% being sick and 25% being healthy. So expected income is EI 0.75 for point B. Okay, this is the scenario when P is 0.75. And expected utility of this situation is here at EUI 0.75. Okay, so this point B's utility is lower than the point if we are getting a certain outcome or a certain income at EI 0.75. Okay, so this utility, the fact that it's concave, tells that this person is risk averse, tells that this person always prefer a certain outcome than a linear combination of a low outcome and a high outcome, no matter what the value is. Okay, unless the probability is 0 or 1. Okay, which is not a certain, which is not an uncertain outcome anymore. Okay. All right. So come back to the distinction that we have talked about. So expected utility and expected income should be differentiated carefully. There's a crucial distinction between them. Expected utility is, if you think of the outcome that is not certain, then it's a linear combination of two scenarios. So it's point A. But if you're getting a certain income at EI 0.5, then your utility at that stage is A prime. Okay, so A prime is not expected utility. A prime is the utility of expected income. Okay. Let me write it down. Expected utility here is A. Utility from expected income is A prime. Okay. For risk-averse person, A prime is higher than A. For a risk-neutral person, usually in a corporate setting, it's usually a neutral situation. So then A and A prime will be at the same level. Or in that situation, your utility curve wouldn't be this curving shape anymore. It would be a straight line. Okay. All right. A little bit more about risk-averse individuals. Synonymous definition of risk aversion is that prefers certain outcome to uncertain ones with the same expected income. So with the same expected income, if it's certain, it's high utility. If it's just a combination of a low and high income, or a combination of many outcomes, it's not as nice as a certain outcome. Okay, so in that situation, we can call this person a risk aversion. Prefers utility from expected income to expected utility from uncertain income. It has a concave utility function, okay, which means that utility increases with income, but marginal utility decreases with income. What happens when a person is risk neutral? If a person is risk neutral, then a certain outcome and an uncertain outcome with this, if they have the same expected income, then it means the same for this person. What if this person is risk preferred, or sometimes we call it risk loving, then an uncertain outcome has a higher utility than a certain outcome. Think of a situation like gambling. Okay, there are situations when people prefers risk more than the situation that is certain. When you think of that, is part of the society that risk loving personality. So for example, people would say that, oh, most startups will die within 5 years, or 95% startup died within 5 years. Then why are there so many people doing startups? Do they prefer an uncertain outcome? Maybe yes. Maybe they think if the startup gets a successful outcome or end up going public, then they will have a really good outcome that makes them not afraid of the outcome that will fail. Okay, in that situation, they will prefer an outcome that is uncertain instead of a certain outcome. Okay. So let's come back to health insurance contract. So in a standard health insurance contract, customer pays an upfront fee. We call that lowercase r, or payment, or insurance premium. If this person gets sick, then this customer will receive Q, which is the insurance payout. Of course, this payout doesn't pay directly to the person. it pays to the hospital, or the healthcare provider, but think of it as part of the income payout. If this person stays healthy, then nothing will be received. Customers receive nothing, but just end up paying the insurance without getting sick. Okay, so two scenarios, very simplified model. If this person is sick, income equals to I sick plus Q minus R. If this person is healthy, then it's just I healthy minus R. Okay. So we model that as let's say IH prime and IS prime. These will be the income with insurance. Okay, so with insurance, income equals to IS prime and IH prime. Without insurance, it's IS and IH. Remember that risk-averse customers wants to avoid uncertainty. Okay. So then if we want to just think of a model that eliminates uncertainty, and think of that as just the most simple model, okay, then this IH prime and IS prime, which is the income after this person gets insurance, this person optimally hope that they are the same, so that the outcome after insurance is certain. Okay, if they are the same, then it's certain. Okay, so we call that full insurance. Okay, full insurance means that there is no insurance uncertainty. After insurance, the outcome will be the same. Okay, so final outcome is IS prime or IH prime. If they are the same, then it's state independent. Regardless of healthy or sick, final income is the same. A risk-averse person will always prefer that. They will always prefer full insurance to partial insurance, given the same price. Okay. So using this state independence, we can solve Q. Okay, so if IH prime equals to IS prime, then IH minus R equals to IS plus Q minus R. Q can be solved, which equals to IH minus IS. So Q, which is the payout, in the situation of full insurance, should equal to the income differences between healthy and sick. Okay, now we want to solve R. Okay, and actually fair insurance, we can solve R, which equals to the premium that the insurance company pay. Okay, so think of the insurance company collects R with without uncertainty or with certainty, and there's a probability of P that the insurance company has to pay Q, which is the payout. So R equals to P times Q. Remember, we already solved Q. So R equals to P times Q, or P times IH minus IS. Okay. So in this situation, insurer will make zero profit or loss from actually fair insurance in expectation. All right, so if we separate them into healthy state and sick state, in healthy states, this person's income is IH prime, which equals to P times IS plus 1 minus P times IH. Okay. In sick state, IS prime also equals to that expected outcome, because we have make actually fair full insurance, right? So sick state and healthy states expected income or the income after insurance should be the same because it's actually fair. So PQ equals to IH minus IS. Okay. All right. As we have seen, simply by reducing uncertainty, insurance can make this risk-averse individual better off. Okay. Remember the previous graph, there is a point A and point A prime. With insurance, we can move this individual from A to A prime, which is vertically higher. So without sacrificing without sacrificing expected income, this person gets more utility simply by getting insurance. Okay. Okay, let's come back to the graph. Okay, so here, without insurance, this person is at point A. Okay, with insurance, we have shown that IS prime or IH prime still equals to the expected income, but because it's certain now with insurance, so we have moved this person's utility from A to A prime. Okay, A prime is higher and our y-axis is utility. So A prime has a higher utility than A. Okay, so in an actually fair for insurance, this customers can achieve a higher utility with the same amount of expected income. Okay. Relative to the state of no insurance, with insurance, she loses income in the healthy states, but gains income in the sick states. In other words, this risk-averse individual willingly sacrifices some good times in the healthy, some good income in the healthy states to ease the bad times in the sick states. Okay, now consider the same insurance contract from the point of view of the insurer. The insurer, first of all, gets a premium of R. And then if this person gets sick, the insurer or the insurance company has to pay Q. There is a probability of P, which is this person will get sick. So there is a probability of P that the insurance company has to pay Q. So expected profits equals to P times R minus Q. So this is when the person is sick, insurance will earn R but pay Q. Okay. If this person stays healthy, the probability is 1 minus P, and the insurance company will earn R. All right, we solve this, or we simplify this equation. Expected profits for insurance company will be R minus PQ. All right, in a perfectly competitive insurance market, we know that profit will equal to 0. So then R equals to PQ. Okay, if it's unfair, okay, if the insurance company has a certain level of monopoly or a certain level of market power that he can charge, that he or she or this company can charge a higher amount of income or higher premium without being stolen from a competitor, okay, without the customers being stolen by the other insurance company, then R will be larger than P times Q. Okay. We should notify that there won't be an unfair insurance for any for-profit company, okay, unless it's a government provided health insurance. Okay. All right. We also want to mention full and partial insurance as we just talked about full insurance. So full insurance means that it will eliminate the amount of uncertainty, right? So then Q, which is the payout, equals to the gap between healthy income and sick income. If this insurance is partial, which means that if this person gets sick, the level of income will still be smaller. Then Q will be smaller than IH minus IS. Okay, so the size of the payout Q determines how full this contract is. If Q is very close to IH minus IS, then this contract is almost full. Okay. All right. So in this scenario, how do we model that? Remember, if we have full insurance, then we are at this point A prime or AF. Okay, this is a full insurance. Without insurance, without insurance, we get, the linear line between S and H. Okay, and then lastly, with this partial insurance. Okay, with this partial insurance, we have this line between SP and HP. So then our expected utility will end up at AP. It's not as it's not as high as AF, but it's still better than A. Okay. Notice that they are still on the same vertical line of IF, which is the expected income without uncertainty. But some level of insurance will increase the utility, and the highest utility will be achieved if we have full insurance. Okay. All right. So conclusion, demand for insurance is driven by risk aversion. A risk-averse person has a desire to reduce uncertainty. That desire comes from diminishing marginal utility from income. Diminishing marginal utility is modeled as a concave utility function that the first derivative is positive and the second derivative is negative. In this situation, for the same expected income, a certain scenario has high utility than an uncertain scenario, or utility of expected income is higher than expected utility of uncertain income. Okay. Risk aversion can explain not only demand for insurance, but can also help explain first, large family sizes. Think of the times when people have to have kids so that they can grow up, earn money, and feed their parents. Okay, so if you only have one kid and this kid died, or this kid end up not being, let's say, profiting or not being able to earn enough money to feed the parents, so then the parents will have large family sizes, which means a lot of kids. So that as long as one of them gets successful, then the parents won't starve when they're old. Okay. In finance, we call that portfolio diversification. In agricultural, farmers scatter their crops and land holdings. Okay. We also want to talk a little bit about the uninsured. This is actually a very unique problem in the United States. So we have a huge population that is uninsured. In 2012, there is 17.7% that is uninsured. So 2012, this is before Obamacare. Okay. Within this 17.7%, 38% of them is below 100% this poverty line. Okay, and so we can see that the uninsured is largely poor people in the country. And remember, we already insured most of the elderly, so these will be people who are poor and not old enough to get Medicare. Uninsured rate among the non-elderly population between 2000 and 2013. So 2013 is still before Obamacare, because Obamacare, the major part of the Obamacare come into effect in 2014. And we can see that this rate increases quite a bit during the Great Recession from 2007 to 2010. Health insurance coverage of the non-elderly by poverty level. This one is similar to the first graph that we've seen. That is, if we look at people who is below 100% federal poverty line or federal poverty level, 20% of them, only 20% of them have employer or other private insurance. 32% of them are uninsured. 48% of them has Medicaid or other public insurance. But if you move up to larger than 400% federal poverty line, then 90% of them, which is 4.5 times higher, has employer provided or other private insurance. And only 6% of these richer non-elderly are uninsured. Okay, so then let's talk about all of these different insurance for a bit. Employer-sponsored health insurance coverage is very unique in the United States, actually. So among firms that offer health benefits in 2013, an average of 77% of their workers are eligible for the coverage. And most of these people are full-time. This makes sense for a company that hires people full-time. It's natural to provide them health insurance. Sometimes it also covers their children and their spouse. But if this person is just temporal or part-time, or sometimes in some scenarios in the gig economy that is booming in recent years, these people can be called employee, can be called non-employee, and even though they work for the firm, there are a lot of times that they are not eligible for the coverage. Okay. The cost of employer-sponsored coverage is the most common reasons that employers cite for not offering health insurance coverage. Okay. How expensive it is. In 2013, annual employer-sponsored premium averaged 5,800, almost 6,000 for individual coverage. And for family, it's way more expensive. It's 16,000. Now we have a lot of inflation. It's been almost 10 years. So this rate has been much higher. Total family premiums, as well as employees' share of those premiums, has risen by over 70% in the last 10 years. So this probably refers to before 2013. Small firms are less likely to offer coverage than large firms. Nearly all business, 99%, with at least 200 workers offer health benefits to their workers, but only 57% of firms with less than 200 workers offer these benefits. Okay. A very small share of people who are not old enough to get Medicare will get their non-group health insurance from private companies. Okay, so we call those private insurance. They cover only 5.8% of the people for the non-elderly. It is more expensive per enrollee than the group insurance plans for the corporate. And it makes sense because when an insurance company sell a bunch of insurance coverage to a company, we can imagine that a company always have people who is younger, who is older, who is healthier, who is sicker, right? So that actually also diversify the kind of like the people's probability of getting sick. However, if a person comes into an insurance company and said that I want health insurance, it is really difficult for the health insurance company to decide if this person has a high risk of a certain very high expenditure of in healthcare. Okay, so an easy way to tell is whether this person has some existing conditions, or if this person has what's the age of this person, right? But there are always information that this person doesn't want the insurance company to know, and for the insurance company to avoid that situation to happen, they would overcharge a little bit to make sure that on average they are still making a profit given the information that they know. Okay, so on average, non-group insurance premiums are lower than those for employer-sponsored coverage. Nationwide, the average monthly premium in 2010 was $215, with substantial variation by state. This class talks a lot about Medicaid and Medicare. So let's first, we all know that Medicare is for people who are above 65. Then what about Medicaid? Medicaid and CHIP currently provide coverage to people, but not to all low-income individuals or people who are not old enough to get Medicare, but are children and their parents, or are pregnant. Okay, so if a woman gets pregnant and come into a hospital without insurance, usually the hospital would say you can go to Medicaid and tell them you're pregnant, and then you can get insurance for the delivery of the baby, and also for individuals with disability. So Medicaid also comes from people's tax, right? So Medicaid finances health and long-term care coverage for 9.7 million non-elderly people with disabilities. Most disabled people get, if they can't get insurance from their employer, they'll get it from Medicaid. Most states have much lower income eligibility for parents than for children. So 41% of poor parents and 43% of adults without children are uninsured. And ACA, or commonly we call that Obamacare, extends the Medicaids to many individuals at or below 138% of the poverty. Or the federal, I think it's a federal poverty level, but some states did not expand that, and some states have different rules. Okay. Who are uninsured? More than 3/4 of the uninsured population are in working families. So uninsured mostly still remains in families with lower income. But a lot of them are actually working, which is not what we think, that these people are not working, so they're not getting insurance. It's actually they are working, but they do not work in companies that provide health insurance coverage. 63% are in families with one or more full-time workers, and only 16% of them are in families with part-time workers. Many low and moderate income workers may find costs for coverage unaffordable. In 2013, worker contributions for employer-sponsored coverage averaged at $380 per month. So imagine if some families earns a minimum wage, then this will be really unaffordable. And $83 for individual coverage per month. Okay, so this is another graph of the characteristic of a non-elderly uninsured. Again, most of them are relatively poor, okay, and most of them are in families that have one or more full-time workers instead of in families that have part-time workers or no workers. Okay. Another kind of coverage is called dependent coverage. So young adults aged between 19 to 25 has historically been at particularly high risk of being uninsured, even though they're young, they're healthy, they have lower risk of getting sick. But they still might get sick. Okay, so beginning in September 2010, the ACA, which is a small part of ACA, that allowed young adults to remain as dependents under their parents until age 26. So this had made the number of uninsured people between 19 to 25 decline by approximately 3 million. Another thing is minorities are much more likely to be uninsured than whites. This is similar to a lot of other situations. Duration of uninsurance. Most of them, if they are uninsured, they remain uninsured for more than 3 years until the time that they get a job which provide them health insurance, or until them gets Medicare. Okay. Coverage by states varies depending on income distribution in that state, the nature of employment in the states, and the reach of Medicaid programs. This is another graph of uninsured rates among non-elderly by states in 2014. We can see that in the southern, this bunch of southern states, it's higher than 12.5%. In kind of like in the Midwest, in the West, it's between 9% to 12.5%. Versus if you look at Midwest and then probably in the East Coast, these states are doing a little bit better in terms of uninsured rates among non-elderly. Okay, so that's it for chapter 7.